Okay, before the break, we were looking at basic syntax of arrays, which is the last of our basic Java syntax. And these examples are going to get much quicker very soon. I just I said something over the break, if you were away from the computer. The examples are going to get much quicker very soon. I've learned over the years to ease into the speed that I do the examples at. And we'll have really big examples that afterwards you'll look back and be like, how did we do 200 lines in a 1 hour class? I try to ease into that in our basic syntax section. That way you get used to following me, how I write code before I actually get up to speed. So sometimes my timing's a little off. There were 2 more things I wanted to do before the break, but it was definitely time for a break, right? We've been doing this for a while. So we saw that we can't extend an array. Our only options would be to make a new array, copy everything over, and make it a little bit bigger. There's some other stuff. I'm going to comment out this random number one. Since y'all go ahead and comment this out too. I'll copy this line. Copy that. Actually, wait. Comment out a bunch of things. All of that comment out. And we'll do a different initial declaration for our array. So let's say we have an array of integers. Again, I'll call it numbers. I'm just going to recreate this. But we want to do some stuff later. Right? And when we actually declare it, we don't know how many exactly what we're going to do, so we need to declare it later in our code. Or declare it here, but we need to define it later. We don't know how many elements we need. So somewhere later in our code, we can do that reassignment like we had up above. Well, numbers is going to be an array of integers that holds 5 elements. So we can split that up. Oh, I forgot the word new. A new array of integers that holds 5 elements. Split that up. That one's probably fairly intuitive. We saw some other similar things, like if we had a bunch of doubles to do math with, right? We can declare them all at once and then assign them later. X equals 3.4, oops, Y equals 2.7, and so on. So we can declare and define in different spots. But with arrays, there is a restriction on that. There is one thing that we can only do when we define it. So that splitting up is fairly straightforward. It's just like things we've seen elsewhere. But other times we might know exactly what data we want here. We know, or we have 5 integers. We know first one's 12, second one's 8, the third one's 62, and we know right when we're writing our code what they're going to be. So we could do like we just did, set up 5 spots and assign those explicitly. But if we know that in advance, we can go ahead and assign them all at once. I can't remember what I just said, 8, 62, 99, 14. Maybe we know those are the exact ones we want. Okay. Whenever we define our arrays that way and just use curly braces, if that looks small on the screen, so in curly braces, enter a comma separated list of what's going to be in that array. That one does have, we cannot split that up. That has to happen when we define the array. So if I come down and say numbers equals that, you'll see it's sort of a problem. So we declared we had this array called numbers, but then when we tried to define something in that spot with that predetermined values for the array, we can't split that one out. So if you define an array that way, it does have to explicitly happen when we define the data, when we define the reference value. Any others you can split up across multiple lines like the other ones. So just pay attention to that. If you use the curly brace to go ahead and put values in there, you can only do that on the very line where you declare that you have an array of integers. You can't do that anywhere else. But that is supposed to be for when we have those situations explicitly. So there's that. And we saw the for each loops, which I'll just put the line break back in and keep that printing. Did I delete this stuff later? Deleted that error message, so print out the things one at a time. Take that out, put that down here. There we go. Format. Put a little comment in there so we can see what it's doing. So we print them all out one at a time with the for each loop, and it's the element, and then a colon takes the place. It's like saying in. So for each element in that array. It's a very useful syntax because usually if we're doing things with it, a lot of times when we do things with a collection, we want to do it with the entire collection, not just a couple elements in there. So print them out one at a time or all at once. But there's some other stuff we might want to do. That's sort of a random order to add those numbers in. Doesn't make a lot more sense if they were just in numerical order. So sorting them, sorts are a big deal. We might look at that some. I usually look at that in the introduction classes, talk about how it's a big deal, and multiple generations of people have spent entire working careers trying to optimize sorting algorithms. So there's a lot out there. And obviously there's some built into the language. And java.util asterisk the wildcard selector, typed that earlier when we did the random number. There's also one in there, one of the things in there is java.util.array. Sorry, arrays with an S. And that particular library has a whole bunch of methods for working with arrays. Bunch of things we'll want. It's in the asterisks. So I wanted to cover the wildcard selector, remind you that's there, because especially on like some of them like Java.util, there's a lot of utility tools that we use over and over and over again in most of the programs we write. So that syntax exists, but if you just use the Control-Shift-I or it switches in different ones, but there's almost always an automatic import keyboard shortcut. If you use that, then it's just going to import the whole one and you'll end up with a bunch of lines. Never have to worry about it. But, so then if we want to sort this, numbers, dot, and there's a bunch of methods here. But see the variable, the length of it, but then everything else is methods. That's what I was pointing out earlier is that's the only variable we can access on that. And you may have noticed that on predictive list already is whenever it goes to pull things up, it's always methods that we can access and never data fields directly. If we need the data field, there'll be a method called get that data or set that data, whatever we call it. Clone equals notify wait. I don't see those things from the array library that I pulled in. Most of this stuff is going to be on everything. So this is another use of that word static that we've talked about a couple times. Static means there's one and only one copy. So certain things, we only ever need one copy. We don't need to create an instance one example might be for math stuff. We don't need to create multiple instances of a math object in order to use our different trigonometric functions. We can do all of we can access all of them from the same math object. So it's a good place for a static object. We only need one. That's another use of that keyword. Means there's one and only one. And arrays, that library I was just mentioning, is the same way. It's a static object. We don't ever need to instantiate the arrays object separate from obviously we have to instantiate an array. We've already done that a couple times tonight. But our library to work with this, like the arrays class, is already there. And then we have a bunch of things as a list, so we can switch it to a list. Searching through it, a bunch of searches. Comparing things. Copy of is a shallow copy. This is going to be kind of important with copy of range and stuff, a whole bunch of things. Y'all can look through that list whenever it's there and get some practice trying to find what you need on the predictive list instead of going to tutorials and looking at it every single time. You have that list, you have the list there, the Java docs right in the IDE. Just try to look through it. Everything should be spelled out nicely. So we have a sort. The sort method is very overloaded. We saw that the other day. We can write multiple methods with the same name and different parameters, and the computer will call the appropriate one. Obviously, it's strictly typed, so we need to at least override it for every type of object we can pass in. In our case, we want we have an array of integers, so we need to sort some integers. And we want to sort numbers. Does anybody notice anything funny about those instructions? So when I sorted that, did I do anything else with it? Like, did I save the sort? Did I say sorted numbers is arrays.sort? As soon as I said sort, our initial array has been sorted, and we no longer have the unsorted version. So this is a very important thing about Java. I'm going to write it really big on the board. Java only passes by reference. And a bunch of exclamation marks. That is a very important thing you will want to remember. So yeah, going back to referring to the prereqs for this class, everybody had Python. Python only passes by value. The exception being list, because there are no values in a list. A list is a collection of references, so there's no way to pass a collection of references by value. But Java only passes by reference. Does anybody know what those words mean? I know some of y'all that had me in class before know what they are. Pass by reference, pass by value. We can also pass by address. We don't do that much on this type of program. On embedded systems, we might, because there's a very small number of things that are happening, and we know what's happening in every single register and bit of RAM all the way through an embedded system. Like the computer controlling the engine in your car. We know exactly what's happening at every single step along the way. But the type of programming we're looking at here, we almost never use pass by reference. Or sorry, we almost never use pass by address. I don't hear any responses. Nobody's really sure what those words mean. May have heard them before. A lot of people see Visual Studio when they're first starting on code and start with VB. The B from basic originally stood for beginner, and it was created by a college professor. Thought it was really hard to get computer scientists on that first step back in 1962. So he made an easy way to do it. And most of our languages are based off some of the syntax things he thought of. Kind of like that thing I mentioned earlier, where we can look and just a word, we know we have a variable, a word in parentheses, we know we have a method, a word in square brackets, we know we have an array. That came from him. He tried to make it simpler, and it worked out really well. And a lot of our languages that have been developed since then copied from basic. They just picked up that syntax because it came out very natural for people. But there we almost always have to say how we're passing it by value. So reference, or I'll go through all of them. So by value passes a copy. So on the stack heap diagram, I'm going to draw this with like some methods. So we have maybe our main method. And in that we have a variable, which I'm on the board. So I'm just going to call the variable X. Obviously it was on type. Typing's a lot easier than writing. So abbreviating it here, and that's going to point at some value over in RAM, maybe a 3. And then we call some method. So our method call adds something to the stack. I don't know, I'll call it do stuff. Put in parentheses, and it's expecting a parameter called Y. So pass by reference, pass by value. And by address, which we almost never do, so I'm not worried about running out of room there at the bottom. So when we call do stuff, we're going to pass in this number that we have stored. We switch over to a marker that works. So then over in that method, higher up the stack, we have this variable Y that refers to something. And if we pass by value, maybe I'll do it in colors. That might be a good thing for color coding. So by value, in our code, we're going to just, when we call that method, we'll say do stuff, then in parentheses put X, and the computer will keep track of the rest of it. But what the computer's doing, if it's by value, we make a copy of this. We make a full copy. So now there's a 3 over here. And then maybe we do some stuff. This method's going to double that. Then at that point, we have a 6 over here to use in our method. That method finishes, and we go back to our main, go back to the caller. Well, our original data has a 3 because the method, we passed it by value, so it worked with a copy. Color code the notes here. So by value, it passes a copy of it. The original is unchanged. What do I call it? Oh, that's the red one. So we also have pass by reference. And when they started cleaning up C++, that eventually became Java, that was one of the things restrict, adding some restrictions so we don't have this unlimited. Definitely get rid of pass by address. You probably already figure out what that means, right? If this is in bit 3712 is where that data starts, we pass whatever's in bit 3712 to that method. That can be okay on an embedded system because we know exactly what's in every bit all the way to the system. So that on a modern desktop, laptop, tablet, phone, most of the things are running with multi-threaded and parallel processing. So what's in any particular bit is going to change constantly. So pass by address is very, very bad in most what we're looking at in the classroom. If you were at the School of Advanced Manufacturing working on robotics, then you'd probably be doing a lot of pass by addresses. But for software development, it's mostly these two. Pass by reference passes. Well, the reference is something specific, right? Like in this picture I'm drawing, the reference is this arrow pointing from the name that's meaningful to us, we put in our code, to the actual data stored in memory. The reference to that. So passes the reference to the data. Because we can make layers and layers and layers of those. So instead of making a copy of it, when we pass by reference, we're going to take this reference value and just stretch that up there. So it is still the original data that's being pointed at. So we're not pointing at some other random copy of it, we're pointing at the original. So if this doubles it and makes it 6, now we have a 6 there. So when our other method finishes running and goes back down the stack, pops off the stack to go back to the caller, that data has changed. That can be a very important thing that you want to watch for. But in the languages you saw in the 2 prerequisites for this class is the exact opposite. Python only passes by value, except for that one instance where it doesn't even make sense because there's no values in a list. We can't have a list of values. Yeah, we're going to talk about lists next Tuesday, and it'll make more sense then. We cannot have a list of values. A list is a whole bunch of these arrows, and that's all it is. We never actually have our data in the list. But in Java, we're always passing that reference. So anytime we do something, we're changing the original data. So you will want to watch out for that. That was definitely different than what you've seen before. So that's what's going on here. As soon as we sorted the array is sorted. We changed the original data, we cannot get back to the unsorted version. That's why there's a copy method. That's why there's a special copy method actually there's multiple special copy methods to make both shallow and deep copies. A shallow copy is like this. Just a quick copy, exactly what it looked like in that instance. A deep copy is a completely separate thing. A completely separate thing that, well, in this picture, this was created when we called that other method, so that's going to be deleted when we pop that off the stack. But a deep copy, that's what a shallow copy is. It's temporary, we'll finish with it. A deep copy is a thorough, completely separate thing, no connection back to the original. And there's methods in this arrays library to work with both of those. Which that's going to be my suggestion when we get to like lab time tonight. Go through those lists. Oh, I'm not sharing my screen. Sorry. Let me go back to sharing my screen. So that's what was happening here. Once we sort it, it is sorted. And those copies and things, which you can pull from that particular text list, and you want to get some practice doing that. Right? Every single one has the name of the method, the parameters we need as you hover over it. If it's from the core Java libraries, the Java docs will definitely be included. And anything else that has Java docs will be included. That's why we always want to include them in the stuff we write. That way, if somebody wants to use it, it's there, convenient and ready for them. And over on the right-hand side, it says what type of data it returns. Get some practice doing your code that way instead of looking everything up. That's what makes you a better programmer. We don't become better programmers by Googling every step along the way. We become better programmers by figuring out how to do stuff and improving our problem solving skills overall, which are also skills that transfer elsewhere in life, right? That's why everybody has to take a certain level of math class, because math class is problem solving. And whether you're figuring out how to algebraically solve for X, or determining a different route when traffic backs up or during rush hour or something and you're in a hurry. That's problem solving. We use the same aspects of our mind and when we're solving problems. So practicing problem solving here will transfer elsewhere, which will help to give you very desirable skills for any employer when you go out to look for things. You don't just have to brag about your ability to code things in Java, brag about your problem solving abilities overall. Because it is a transferable skill and it takes a little bit of practice. So we can sort that. I think that was the last two things I had on the notes there. There's a bunch of stuff in that library, and use that to kind of start figuring out what you need from the predictive text list or the official documentation automatically, but we already saw the predictive text comes from the official documentation. Oh yeah, the string. I wrote it on the board earlier. Let me do a couple quick arrays. Let's do it. A double array, just making up some name, is new double with I don't know, I'll put 6 things in there. Then like we saw before, oh whoops, I forgot square brackets. Put brackets in there for in a regular for loop for integer I starts at 0, I is less than double array.length, I plus plus, all stuff we've seen before, and then double array index I is come up here and uncomment that line, so we still have random numbers. Random dot, it's type specific. We have to be explicit about what type we use. And the predictive text got it right there. Last time, you might remember last time, next double was the second thing on the list. The very first thing is Hashcode. You probably know that word. We're going to talk in detail about what hashing is when we get to data structures. But hashing is always going to be what the computer wants to do. Computers operate hashing at every level. And so when the computer's predicting stuff, it always wants to just hash it. It's like, oh, this will be best. But it's a computer thing. We will talk about that in detail soon. But the second thing it predicted was next double, which you probably would have guessed anyway, right? I'm hoping you would have guessed that at this point. Starting to get used to seeing how Java spells everything out. And now I'm going to do the other for each loop with something other than integers. What is that? Oh, oops. Double with a lowercase d. We do have double with a capital D. We do have an object version that has methods built in already. We will see those soon. Actually, it might be in your reading assignment for this week. I'll double check whether it's in the reading assignment for this week, next week. We'll see those on Tuesday either way. So we're going to do a for each. So our array is holding double type of data, double precision floating point data. Whoops. Oh, let's retype that. So our type for the for each is going to be double. I'll just call it D, and then a colon, double array. I should probably put an extra space there to make it easier for reading. So that's the for each. So like for each D in double array is how we would read that. So for each is kind of implied, each thing, and then the colon's in this array. Then I'll just print it. S out D. Or actually, take out the line break and S out D plus a comma. That way we can see all of them. We already saw how to format it nicely. Talk something about formatting it nicely. So there's a bunch of random double precision floating point numbers. But the key thing there, I wanted to something else in order to look at the for each loops, because that using integer data earlier didn't really give us a clear example of the difference between that and the normal for loop. Because the normal for loop always uses integers because we're just referring to the index. And an index is, right now an index is always going to be an integer. Very soon we will have options on that. We'll have lots and lots of options on what our index is going to be. We have lots of control over this. The other one that I wrote on the board earlier, does anybody have any questions about that before I show the other thing I wanted to show? I'll put it down here at the bottom. So maybe we have a string. We'll call it, I don't know, sentence. Is this is a long string with a bunch of words. And a bunch of words and other special symbols like a colon. Figure that out. I didn't see that. Gonna figure out what's underlined at first. So just a long random collection of data, or random collection of character data, which is an array, so we can refer to each one individually. Normally we wouldn't do that. We use special methods to pull those out and things. But the one I wanted to look at is create an array of strings, call this words, and that'll be sentence ENCE dot split. And notice we have a couple options, split with regular expressions, split with regular expressions, and a limit to only do so many. Let's use the regular expressions. So if we had just one symbol, we could put it in there. Not like this though. Notice that it's underlined. Maybe that box will go away. Oh, it didn't underline it. That one's still, it's not gonna like that. It's gonna throw an error if I run that. Oh, it doesn't throw an error. Oh yeah, because we're looking for regular expressions, so it's expecting a list of things. In some situations, it might be looking for a character in particular. Oh, I guess it is looking for a string. We can only enter regular expressions. So we actually want to enter a string and then square brackets to indicate, and then inside of the square brackets, list out all the characters we want to split this sentence on. And it is not a comma separated list. We're used to those. Just list them out because a comma might be something in that list. In this case, a comma is going to be something in that list. \S is the escape sequence for a space. If you want to see that. \B is backspace. That can be useful. T is tab. I'm going to erase those. I was just pointing at what they are. Alternatively, since we're typing, it's easy to tell when we just push the space bar. So you can just push the space. So split that up on spaces and commas and semicolons. And I think that's all that I put in there. Oh, there's a period in there. So I'm going to split it up on all those symbols. And so the comma can be one of them. We want to make sure and include. So we can include a comma. We can't use comma separated lists like normal. They are, and it is regular expressions. So your \W, \DE, asterisk, all the normal regular expressions. We'll talk about those briefly at some point. But that's something that you just read from a list and memorize. So there's really not much I can say. It's pattern matching. If you haven't seen it before, we have a shortcut ways to type patterns for the computer to look at, but it's copying things off a list. So it's going to be like 5 minutes in class, and then I'll point you towards some good reference for good versions of that, nicely formatted versions of that list that you'll copy those things off of. Strictly memorization thing. There's really not a lot to say. It's a special way of pattern matching, but when we need that, in regular expressions go inside of quote marks, inside of square brackets. And we can just list out all the things we're looking for is the easy starting point. Then I'll just do a loop. So for string word, I'll do W in words. Print out W. So we've already seen that part. Just before each loop to walk through our array, because usually when we want to walk through an array, we walk through the whole array. And you see that's that very, very common pattern, very, very common thing we do of splitting up arrays. And I highlighted that. Notice that those empty lines aren't spaces. All the spaces were deleted. So like when we split on things, if I look back at the string, this is a string, comma, space, and we're splitting on commas and spaces, but there's nothing in between there. So those empty lines are just holding null. It's not a space there or anything. So be careful when you set up selection structures to look through those. Another thing you want to practice, that's a very common one, so I didn't include it right off the bat. Any questions about that? That's why I'm going to talk about it with the single dimensional arrays. Okay, I'm gonna go ahead and erase the board. If anybody has any questions, go ahead and speak up while I erase this and extend this to make the obvious extension on this. Let's go try. Let's see if this marker works better. Oh yeah, that works way better than the other black marker. So for this, I'm going to draw 2 stack heap diagrams. For the actual version. And then the one, what we're going to think about. How we're going to think about it most of the time, unless it's one of the times we really need to dig into the actual version. So we saw an array is pointing at some predefined spots in memory, a collection of data. Each one, I'll go back with that earlier data, each one's a byte. So we have 8 bits here, and then 8 bits here, 8 bits here for a byte. But we saw we can do any type of data there. So it might not always be 8 bits. Maybe we're doing a bunch of 32-bit integers. And we just saw, so each one of those blocks is 32 bits. was how we put strings in there. All of our other types, the booleans, custom objects we haven't used yet, or we haven't really gotten into yet. We've been making objects like, what was this example called? Did I even give it a name tonight? So we could make a whole bunch of Java application 12 objects. Java application 12 J1 equals new Java application 12. Or we could make an array of those. Java application 12 square brackets ARR, so that's the array for that's a meaningful thing, equals new Java application 12, and then put maybe 7 in square brackets, and then we have a spot to store 7 of those, 7 of these programs we're running tonight. We haven't really got into custom objects, but whatever our size is, we can, any of our data types, we can kind of put in those little blocks. I guess the natural extension on that is, well, an array is a data type. We have to use that new keyword, right? Array of integers equals a new array of integers. So can we put an array in there? And obviously the question is yes. And then we get the same thing we have here. So if we want to store another array in there, we put pointers to other arrays. So then this first box points to another array over there in memory somewhere. And this one points to an array in memory there. This one has that reference to another array in memory. So an array filled with arrays. And that could continue. Seems like there's only room to draw up here, so maybe this first one, array of arrays, is pointing at another array. And the first one has 4 elements in it. The second one has 2 elements in it. The third one has 1, 2, 3, 4, 5 elements in it. So we call those jagged arrays. Because, well, when I get over the way we're going to think about it, it'll make more sense. But we're not restricted. They don't all have to be the same size. But basically the idea is we put arrays inside of arrays. And this is the actual picture. Sometimes we have to think about that. Big complex situations, and then that issue I mentioned earlier where our program, we're running a really big program and we start doing very heavy demand on how much RAM we need, we might mess up other things that are running on the computer. Right? Like all the bugs are fixed in our program, but it completely crashes on Microsoft Word every time we try to run our software. That's going to annoy people pretty quickly, right? So things like that is when we have to fall back on those actual versions. There's a much better way to think about this. I'm going to ignore that jagged part. That was just to mention the jagged word array and make a nice little square one. So all these have 3. What we're going to think about is there's a better way to format that. So instead of our initial one kind of going acrosswise, we think about that first one going down, and then the other ones go across. And we end up with a nice little table. This is how we're usually going to think about arrays inside of arrays. And then I guess a third dimensional one, you can kind of think about it as like on a table stacking things up. Right? So if we had another one here, we could think about it like this cell has things stacked up in that cell. Beyond 3 dimensions, it's really hard for us to visualize. We can deal with the numbers. We can keep adding them on indefinitely until we run out of RAM. But 2 dimensions, a table, that gives us a really nice organized structure that a lot of us are used to working with. And for 3 dimensions, you can think of things like stacked up on that table. But beyond 3 dimensions, it's really hard to visualize. Humans aren't very good at visualizing 4-dimensional space or 11-dimensional space or and any of that stuff. Anything beyond 3, the ones we normally exist in. But most of our situations are going to be 2 or 3 dimensional. Actually, by far, the vast majority is going to be 2 dimensional, and we have a nice little table to work with. And then a jagged table is like this. It doesn't have to be square. It's not a relational database. We don't have to have that precise definitions of every column and that restricted stuff. Unless we're connecting to a relational database, then we probably want to avoid gender arrays. But we don't have to have it perfectly square. However, our data stacks up, it'll work fine. So we're usually going to think about this, but every once in a while, and usually when it's in a difficult situation to deal with, we do want to keep this in the back of our minds, what's actually happening there. And that is that our initial array is just filled with a bunch of references. And those references point to other arrays. And as the dimensions increase, those references point to other references and layers and layers and layers of references. Which, like I just mentioned, if we have to think about that, it's usually a difficult situation already. And it's not one where we're going to think about it for 10 seconds. It's one where we're going to be drawing on whiteboards and fill up notebooks and spend a month on. It's really hard problems, but those don't fit in the time constraints of a classroom with all we have to cover. So just keep that in the back of your mind, that actual picture is something you will have to occasionally deal with, but it's never going to show up in a classroom because dealing with it does not fit in the time constraints we have to work with in a classroom with all the stuff we have to cover. So back to the mind thing, but it's not hard to put it back together. It's just that one's much more useful for the basic putting together an algorithm. We think of a table and then we organize our data into tables and keep track of it that way. So the syntax for that, I guess that is the main method, so I need some more stuff up here, is probably what you would expect. I use byte data. I haven't used that yet. So an array of bytes, but that array of bytes, I want an array of bytes, kind of like this picture. I want an array of an array. So we just added second square brackets on it. Most of our languages, there's really only 2 ways we see them anymore. We either have 2 sets of square brackets or we have 1 set of square brackets with commas because we get rid of those middle ones. If we need 3-dimensional data, we add an array of arrays. I'll just do 2, so then we have a nice little table. I'll call it table. Oh, it's bytes, so that would fit good with characters. Well, I won't do that. I was just thinking about your homework assignment you just turned in, those ASCII tables. Some labels on those would have been nice. It seemed a nice 50-50 split for how many people labeled that table and said like the number equals the character versus just bringing out the character. I counted it correct both ways as long as it didn't crash, but I thought about putting those comments in the gradebook because it was a perfect 50-50 split on the homework I've seen so far as to whether or not you labeled the ASCII table and didn't just say that, turn out that, hey, you actually said like A is number 65 or 97, capital or lowercase. But a 2-dimensional array would be a much better spot for that way to organize that thing. So again, it's going to be a new collection of byte data, and let's say 3, 4. Which in the picture here, as we read it left to right, it's the order of the reference. So the 3 would be the first one, and each of those 3 has 4, comes out to 4 things. If it's not too small on the screen, I'll draw another box there. Each of those 3 comes out to 4 things. Or on a table, rows first. We have 3 rows and 4 columns in each row. Actually, if I'm going back to the picture, I should stop the screen here. So a 3, 4 would be we go to 3 first, and then each of those 3 things has an array with 4 items in it. Or on a table, 3 rows, and then each of those rows has 4 columns. This is the way you're going to think about it for putting together your algorithms. This is when we hit problems, when we hit big problems and have to figure out what's going on, because it doesn't make a lick of sense, because computers shouldn't be acting the way we're to produce the results we're seeing, and we have to spend a long time figuring it out. You won't see those till well after you're done in the classroom. Be prepared for them. They do take a lot of people, it gets taken by surprise. So they sit through the classroom, everything was already designed to fit in our time constraints. Then they get out in the working field and are immediately handed a big problem. They find a job programming, and then the first thing they do is sit there for a month, for 6 weeks thinking about it. And a lot of times that 6 weeks will, if they do it in 6 weeks, they'll really impress their bosses. Like, wow, we've been thinking about that for 6 months and haven't got anywhere on it. So that does sometimes catch people by surprise when you move from the software development classroom to the software development career. Be prepared for the hard thinking. This field is about problem solving. We don't get paid big bucks for typing. Typing's easy. You don't get a lot of money for typing. Typing's tedious, busy work at the end. Finishing this example out, you can probably predict it already. We saw with loops, we need to, or with one-dimensional arrays, we have to loop all the way through the array. And we know how big the array is, so we'll use a for loop most of the time. While I is less than table dot length I plus plus. And I'm going to change this in a second, because again, a lot of people start with i's. There was a time where we needed to be cautious with RAM, but what we type here is not what runs in the computer RAM. It gets compiled, changes into something else. The computer is never going to see that we called that I. So a very common one, a lot of people still like to do I for index or integer, and then for our second dimension, J is very common for the letter after I in the alphabet. Anybody notice anything wrong with this logic I just put on here? Other than the fact that I can't seem to spell length. There we go. Does something seem off with that? With that logic? Any thoughts? Anything seem a little off?
It's trying to give the length of it 2-dimensional, but you can't figure out how to do that.
Yeah, those aren't the same number. Our condition should not be the same number there, right? So one of those has to be different. And remember, it's an array filled with arrays. So we have a one-dimensional array and then another one-dimensional array stuck inside it. So our outer one is going to be that initial array. And that one has a dot length. And our inner one also has a dot length. So that now points at the outer array, from the row, each row in our table, and then each row has a separate length. So you want to watch for that and think through which one the brackets go on. I mentioned it quickly, but make sure you keep an eye on that and pay attention to which one your brackets go on. a lot of people like to do it that way, and then I'll put some random numbers in there. Table element I, J. So it's double square brackets, so just two sets of brackets for an array filled with arrays. And that's, well, we still have our random thing going. So random dot oh, random doesn't seem to be predicting much useful stuff for us here. There's next int, next long. It didn't really give us a short list. Next float, next Gaussian, next int, next long, next seed. Oh, there's next byte. Sort of. It's not really next byte though. It's next bytes. And it returns an array of bytes. So that one behaves a little bit different. So on this one, I'm going to comment these lines out and just do that directly. Let's put some small bytes in there. It's 3x4. So I'll just do the manual thing. And each one's an array. So we need to nest. We need to have those nested. So inside the curly braces, oh, I don't know, 1, 2, 3, comma, then another array, 7, 9, 15, and then 22, 24, 26. So notice the sort of the same thing, the comma separated list is a comma separated list. So sort of the same concept we were talking about earlier, just extend that out. If you declare your arrays explicitly, they just get nested inside there. So then instead of filling it, we'll just print it there. So S out. Table element I, J. Yeah, I'll print this once and then come back and fix it. Does all that make sense? We see how it grew from the earlier things. So we can see there, it printed out all our numbers, but I just made a big deal of how we're going to think about that like a table. So we probably want that to print like a table. So one good option, if I can find the right section of code. Okay. So the outer loop is our first index. So that's like our rows. The second inner ones, the second ones, that's like our columns. And we can think all the way through that. Or to make that even easier, we can change all these I's to say row. And all these J's to say column or call. That was an I, so you just place with row, column, and row, column. And instead of using I and J, like so many people do, and you will see in so many tutorials, especially for 2D things, it's really going to help with your algorithm if you call it row and column. So that one happened quick. Does everybody see what I did there? Any questions on the chat room? I'll give it a second for things to type. A fairly easy concept, but hopefully that makes a lot of sense now, because now when we start to think about where we want to put that line break, it's a lot easier to see which loop needs the line break and which one doesn't. Okay. We want to break. So this is our column loop. So we do not want to break in the columns. We're going to put maybe a slash key for a tab. Oops. Plus slash key. And we'll put a tab on each one And then after the last column, then we'll just do an output. I'm gonna leave that blank. I don't think we've seen that yet. We could put an empty string there. But print line has a line feed on it. So we just say print line and don't put anything there. It's gonna print a line feed. So we'll add some tabs between all our numbers, and then a line feed at the end of the row. And just a subtle example of looking at where it's much easier to see the usefulness in good variable names. And when you look at tutorials and examples, and I think our book is really bad about it, they're almost always going to write I and J. But keep good names in mind. It can be very helpful. Anything else I want to say about this? I have a note in the margins on my notes that says, go ahead and try chapter 8, but you won't be tested over it. So I don't think chapter 8 is included, but there will be some things that are useful for you there. Let's look at what chapter 8 is real quick. Anybody have any questions about arrays? They're very straightforward. The big thing is, even though in the prerequisites for this, you would have called something arrays, you didn't actually work with arrays. And in the prerequisites for this, you were always, you were always using a language that passed by value. So anytime you had a method or did stuff in methods, you were working with a copy. But in Java, we only pass by reference. So remember, you are always working with the original data. I tend to use the same types of pens, so I can't even tell when that margin note was written. It was definitely written with the big crystal pen, because anything other than the big crystal pens now just throw them right in the trash can, because they're not going to work for long. Chapter 8. Multi-dimensional arrays. Okay, so it's all about multi-dimensional arrays, and there's probably not anything in the homework about that. Where are we at? We're in module 2. The 16-week class stretches out for a while. Programming assignment. Oh, I didn't include homework permit. Never mind, that's an old part. That's an old note. Multi-dimensional arrays. So, well, there's the homework if you haven't looked at it. So you have an exercise from the array chapter, an exercise from the multi-dimensional array chapter. And then you'll come back and do the same thing with lists instead of arrays. And lists are the ones you would have worked with in the other language, even though we don't use that word when we're talking about them, except in like formal lectures. So the same assignment twice, just with different types of collections, and we'll see the other ones on Tuesday. Now is probably a good time to practice this. I forgot to do the GitHub stuff, haven't done that in a moment, so let's put this on GitHub. So I'm going to change directory over to the documents/delete folder. What's in here? I'll make a directory called Git Stuff. Change into that Git Stuff directory. Git init for initialize. So initialize dot. Hopefully on your screen, on my screen right here, it looks dusty, so it's hard to tell the dots there. Hopefully on your screen, you can clearly tell it's git init dot, and the dot refers to our current directory. So we initialize that as that folder as a repository. Now git add origin https:// // means protocol. Before long in our class examples, I'm going to say type this protocol and just expect you to know the : / is there when I say type protocol. So hypertext transfer protocol to github.com, Francis-Chris 5 is my GitHub accounts, and there's a repository on there called SDEV 200-fall 2022.git. If you just want to navigate to it, you just need that URL without the file extension at the end. But the .git is important if you want to do stuff with it. Uh-oh. Well, that might not be what it's called. SDEV 200-fall 2022. Okay, that should have been what it was called. Git. Oh, I forgot remote. I forgot a word. Git. Remotely access a new origin. We'll add an origin to our remote access list. Sorry about that. GitHub.com, Francis-Chris 5 / SDEV 200-fall 2022.git. There we go. No error message. Should work. Then git pull that origin we just added, and we'll hold on the main branch. So I don't have anything else. And when I grade your homework, this is what I do. I'll copy and paste that link you gave me, or follow that to the top level where I can click the green button and copy the link from there. And I'll just go through this right here. I'll make a folder, hold on the origin, or connect to the origin, pull the origin. You can pull stuff all day long. You do have to have permission to push back out. So I can't push things back in your repository. But that's what I do for grading. Then I'll start, so obviously grade the files and then delete them from the computer. But here, I need to add some stuff to that. So if I go to File Explorer, I've been doing autosave all night, so I better make sure this is saved. Save all, looks like the save all button's grayed out, so it's good. In documents, NetBeans projects, here's the one from tonight. That's why I keep deleting them, because I'm not giving them, I keep not bothering to give them names or anything. So we'll copy that over to in the delete folder, the Git stuff folder. I'll add a name here. So new folder, things about arrays. That's why it's somewhat organized, and I'll paste that project in there. So that's all there now. Come back over here and say git add dot. So add the current directory, and whenever you do this, that is automatically recursive. So it will go through all the subdirectories. Git add anything in the current directory, and that if you use the dot, that includes the recursive call. So git add dot, and now we need to commit to those changes. So git commit stuff about arrays. Give it some sort of meaningful name or message so that we can tell which particular push to the repository it was. We need to roll back the clock to it. Or if we're in different branches, tell which ones get merged and which ones don't. All of that stuff to keep it organized. So it added the new files. Looks like there's 11 changes, 2032 lines inserted. Way more than we typed in class tonight. Those automated things are kind of nice, because that's tedious typing too. That's like XML file saying go to the C directory and make a file called, give it the project name, make a folder called libraries, and copy all the Java libraries from the language installation over to that folder. Very, very tedious stuff. It's not hard to type, but it doesn't take a lot of thought either. So perfect things for a computer to do. So So now that that's committed, we can, just like we pulled the origin down, we can push the origin back up. And I'm just gonna push it right back onto the main branch. There we go. So the stuff from tonight's on GitHub now. You can go over there and see that. Download all that, but that's how you do that. You'll do that from the terminal. It's a lot easier. Next time I'm gonna look at when you downloaded Git SCM from those instructions. There were several of them, including a GUI. I'm gonna look at the GUI next time, because there'll be a little bit more time at the end. It has some, actually the Git GUI, the local client I think it has the absolute best version of the history, where we can see all the changes to that repository over time. They're best organized on the local client, Git GUI. So it is definitely a good one to look at sometimes. But that's all the examples. Does anybody have any questions about arrays? And next Tuesday, we'll look at lists, which are the dynamic ones. So we can change the size of it, make lots of modifications and stuff. There's some overhead that comes with that. This, if we know exactly how much space we need, is much, much faster. That's the biggest thing I'm doing it. It's faster, easier on the resources, so no matter what we're trying to optimize, the pure arrays will give us the optimization every time. Because everything else has overhead that comes with it for the other functionality that we get with. But we will look at some of that on Tuesday, because it's a lot easier to use and we're humans and we probably want to do it the easy way every chance we get, right? If there's no other questions, I will see you all on Tuesday. Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. And otherwise, have a great weekend.